From Friday, I was using this. I shared my screen. Can you see this, sir?
Can you share your screen?
Yeah, just now I shared.
Okay.
This one. One is successfully scanned. Other one is
Currently managed. Yeah, that is fine. Okay, so click on continue.
only one, sir. One only is there. But
No,
when
because it is already, it says that it already installed.
But when I'm going inspection cluster, only one is saying that inspection is not taking place.
Okay, in that case, okay, so you need to delete this entry from host this one.
Yeah, I did many times, multiple times.
No. You need to delete this one, okay, from backend RDBMS.
Then how to do that? I am not getting.
Okay.
I tried many times. But same thing I am able to see. Same thing I am getting again and again and again.
Okay. You know CMG backend database, right?
Not exactly, sir.
Give me the control.
Yes, sir. The SCM also is coming, sir, in the database. I don't know why it's coming. Oh, thank you. Thank you. Thank you very much.
Okay, sir. Next. Yes, any questions?
Sir, I have a doubt now. One regarding this Zookeeper installation. Shall I share my screen?
Please share your screen, sir.
So these were the steps you told us to follow with respect to the new document for Zookeeper installation.
Yes, sir.
So I have completed this.
Okay.
So after this, do I need to follow this again? All the steps again?
No need, sir. No need.
Because it's a fresh installation.
No. It is already there, right? It is already there, right? No, sir. Okay. If you're doing fresh installation, then you can go directly with these steps only. Fresh installation. These are the steps for fresh installation only. What I told, okay, suppose, okay, if you already have a cluster, okay, which is installed with 3.4.5, then okay, you want to change it to 3.7.0, then okay, you need to follow those steps. Otherwise, okay, you just follow directly. This is 3.7.0 only.
So I followed the text. So from where will I start in this document?
Okay, continue then. Okay.
From here, I have to start follow from some of the Zookeeper command.
Yes. From here. Okay.
From here, I have to follow.
Yes. And you need to follow these also. Yes.
Okay, sir. Fine.
Okay, sir. Okay. So, guys, any other questions?
Yes, sir.
Yeah.
Harton was while installing, I'm getting.
Okay, show me.
So I'm stuck.
Okay, wait.
Here in step is not listing.
Give me control.
Okay.
ఇక్కడ క్లియర్ గా చెప్తుంది కదా జీపీ మిస్ అయిందని.
అది ఎక్కడ అనేది అర్థం కాలేదు.
ఓకే దీంట్లోకి వెళ్ళి గూగుల్ డ్రైవ్ ఉందా?
ఇదే
గూగుల్ డ్రైవ్ కదా, ఎక్కడది?
షేర్
ఓకే
కింద హడూప్
ఎక్కడది? వెయిట్ ఓకే స్టెప్ 2 లోకి వెళ్ళి అటోనమస్ 3.1.0 కదా, ఫోర్త్ ఫైల్ ఉంది కదా GPL లో, ఇది ఎందుకు డౌన్లోడ్ చేయలేదు?
అది నేను డైరెక్ట్ గా 4 హ్యాపీ చేసి యాక్సెస్ చేశాను.
లేదు ఫోర్త్ అవ్వలేదు కదా, అక్కడ చూడు 3 ఉన్నాయి చూడు, అక్కడ డిస్ట్రిబ్యూటర్స్ ఉన్నాయి, GPL లేదు కదా, అదే లేదని చూపిస్తుంది ఇక్కడ.
ఓకే ఐ ట్రైడ్. ఓకే
అర్థమైంది కదా?
ఓకే ఐ ట్రైడ్.
ఓకే నాకు డౌన్లోడ్ దట్, unzip it. Okay. Yeah. Right, any other questions guys? You have 2 more minutes. Okay, if no questions I'll share my screen. Yeah. Okay, so we were talking about transactional tables last week. Okay, I mean Saturday we were talking about Hive transactional tables, correct? Any questions on this? Any questions on this? No questions. Okay, so then okay.
Sir, can we do bucketing as well as partitioning on same file?
Yes sir, and not on same file. Okay, you can do partitioning on country wise under that bucketing.
Yeah.
Okay, yes. Okay guys, okay, so now you all know that we have a Hive. Okay, so we discussed about Hive transaction tables. Okay, now we need to talk about Hive execution engines, guys. What are this execution engine actually? So we understood that. So what Hive will do whenever somebody submit a command to Hive, Hive will compile the query and check if this is a direct select query. Okay, if it's a direct select query, yes, it will execute it by Hive itself. Or if it has some consolidation or any kind of computation on top of the inside the query, then what it will do, it will take the help of Yarn. Okay, so when it comes to Yarn, Yarn has 2 different engines. Okay, so one is MR execution engine, other one is Sage execution engine. Okay, what is the difference between these 2 execution engines? Okay, so normally, okay, so let us take MR execution engine. MR execution engine. Okay, it works in MR execution engine. Okay. So normally, okay. Okay. MR engine. Okay. Well, let's say you are executing query 1. Okay. You are executing query 1. Okay. So let's say, okay. So this query requires, okay, yarn help. Then, okay, what I will do? I will contact yarn. Okay. So yarn will give application ID. Okay. This is the application ID. And okay. So first, okay, what it does, what yarn will do? What yarn will do is, first it will launch application master. After that, okay, it will launch the required number of mappers. Think that, okay, so this is the, okay, you for this job, okay, for query 1, you require 2 mappers. Okay, and one reducer. So how many resources it will use? Actually, 1 application master, okay, 2 mappers and 1 reducer. Normally, what is the application master size? 1 core plus 2 GB. What is the mapper size?
1 core 1 GB.
1 core 1 GB.
Okay. So AMA size of 1 core 2 GB. Okay. So default mapper size
1 core 1 GB.
plus 1 GB. 1 GB. Okay. Default reducer size same.
Same 1
Okay.
core 1.
1 core 1 GB. Okay. In this scenario, if I go with this model, okay, for application master, how much it will take? 1 core 2 GB. Per mapper, 2 mappers. Each mapper 1 core 1 GB. 2 GB, 1 reducer, 1 core 1 GB. So altogether, how much it will take? 5 GB, 5 core plus 5 GB. Yes or no? Or 5 GB plus this one. Correct or not?
Yes, sir.
Okay. Okay, let's say I'll put plus. Okay, I'll change there only. 2 GB plus 1 core. Okay. This is 1 GB plus 1 core, 1 GB plus 1 core. Okay. So you have application master, 2 mappers. Okay. So 5 GB plus 5 core it will take. Okay. Let's say you're running second query. Okay. Second query will get the second. Okay. Second query will go like a new query to resource manager. Resource manager will give 1 more application ID. And okay, it will launch 1 more application master. Okay. So for this also 5 core 5 GB. Okay. Okay, like this, okay, every query you run, you will have a separate application ID, okay, separate application ID, separate application master, separate mappers, and separate reducers. Correct or not? Huh? If you run query 10 times, okay, you'll have 10 application masters, 10 job IDs. Correct or not? Okay. But okay, when it comes to Tej execution engine, okay, so it works like this. Okay. So normally, okay, when you execute Tej when you use Tej execution, when you run first query 1, okay. So here Tej session will start. So here will start. Okay. When I execute query 1, first, okay, this session will start for the first query. Okay. And okay, so this will get, okay, one application ID. Okay, you will have 1 application master, 2 mappers. Okay. So to execute first job, it requires, okay, this much. Okay. And second query, will you have, okay, same job ID? Okay, I will show you example. Okay, I will show you. Okay. So now I'm running a query. Select sum of employee salary. Valid session. Okay, no problem. Okay, I'll start it once again. Okay, I'm running a query, guys. Okay, now you see. Okay, when I run the first query, what it is doing for the first time. Okay, I'm running for the first time. It is starting my session. This session will start. Okay, it is starting my session. After starting my session, okay, it launched mapper 1. Okay, so for this, what is the job ID? There's a job ID. There will be a job ID. Okay, what is the job ID here? Underscore 001. Correct or not? Okay. Now, when I run, okay, different query, select count star from employee. Okay, so okay, select count star. Okay, where salary greater than 30,000. Salary. So now I'm running second query. Okay, see what is the job ID it is giving. What the job ID it is giving is for second job also. So normally Yan received 2 jobs now. Okay, for every job, okay, you should have for every job, okay, you should have separate job application ID or job ID and okay, separate mappers and separate reducers. Okay, but here what is happening? Okay, when you start, okay, when you start first job, this session will start. Okay, and okay, this session, okay, will have one application master. This application master will take care of okay, this mappers and reducers. Okay, until this session is closed. Okay, whatever queries you submit, okay, all the queries will be taken care by application master itself. Understand? Now the question is that okay, when this session will end, if you don't submit any jobs for continuously 5 minutes, your session will end. Suppose okay, if you are continuously submitting without 5 minutes gap, you are continuously submitting jobs for 2 days. Yes, the same session will be up and running for 2 days also. Understood? Understood or any questions? So it means okay, so one application master will be taking care of multiple jobs here. Okay, what is the advantage here? Okay, if you use this stage execution engine, what is the advantage? Okay, if you use MR execution engine, what is the advantage? See here, okay, if you have MR engine, okay, for every job, okay, you're launching separate application master. Okay, separate application master. Okay, but here, okay, only one application. If you run 10 jobs, 10 application masters. But if you run 10 jobs, you have only one application master. Okay, it means okay, 9 application masters resources will be saved. 9 application masters means okay, what is the size of each application master? 2 GB plus 1 core. 9 application master, 9 2s, 18 GB. Okay, plus 9 ones. Okay, 9 core. Okay, so this is the saving. Okay, you can see when you go with the Tej execution engine versus MR execution engine. Got it? See here. So here, okay, overall to execute all 10 queries, okay, it is taking 55 GB, 45 cores. Okay, but okay, when it comes to Tej execution engine, okay, it is taking 37 GB plus 36 cores. So the savings are 18 GB plus 9 cores. Got my point? Okay.
Sir,
Yeah. Any questions?
sir, that
Okay.
means this one application master will launch
Take care
all
of
these
multiple
mappers
jobs.
and
Yes.
that only one application master.
One
will launch?
application master will take care of all the jobs now.
Okay.
Got it? Until the session is up and running. Okay. So for the first query, your session will start. Okay. And your session will be keep on running. Okay. Now if you go and see here, okay, if you go to Resource Manager UI, now I will take you to Resource Manager UI.
Sir, we run at a time for the 10 jobs.
All 10 will be taken care by single this one only. Okay.
Sir, in that case, performance of the stage will be good, right, sir?
1 second, sir. 1 second. Okay. I'll take you to Yan. Okay. Resource Manager UI. Okay. Now, okay, you see applications. Okay. See here, guys. Okay. So for 001, when it has been completed, still okay, it is showing like running only. Correct? Job is completed and we got the result also, right?
Yes.
We got the result also. But why is still it is saying okay, job is running? Because okay, for next 5 minutes, okay, it will be active state only. Okay. So here, okay, so you can see, okay. Okay. Again, I'm running. Okay, still okay. See, still same ID. Or no? Okay. Until okay, you have. I mean, okay, you don't submit. Okay, jobs for next 5 minutes. Okay, so your application will be still in running state only. Understood? Understood, or any questions,
But
guys?
then how can we identify the queries?
Normally, actually, okay, so how to identify? Okay, so here, okay, we have something called Tej View, guys, actually. Okay, application information. Bring on this machine, informations. Okay, can you? Okay, no.
So by default, all jobs will run in Tej, or we need to specify?
It depends, sir. It depends, sir. Depends.
Okay.
It depends. Okay, so you can specify what you want. Sir, can you see this one? Okay, every time. Okay, so now time okay, 7:13, right? Okay, I'm running one more query with same ID. Okay, now you see. Can you see this one?
Yes, sir. Yes, sir.
Huh?
Yeah.
So this is what it is. It is completed actually. Can you see this one?
Yes, sir.
Huh?
Yes, sir.
Okay, every time. Okay, so this is how you will be. But okay. Can you see this one? This query actually. Okay. So every time I cannot manage. Okay. This is application master, still it is in running state. Okay. Just run on this machine, that's it. Okay. But if it is failed, okay, I know how to show it. Okay. How to say to check this information in the Tej UI, but Tej UI they disabled from 3 version actually. Okay, so this is fine. Applications activity. But actually it is showing here it is showing here, but okay, but not exactly actually. It is failed. Okay, so it is completed. Okay, so where I can see the loss, it is showing only the node manager information. That's it.
Yes, sir.
Huh?
Then let it be, sir.
Yeah. Let's not waste time, guys. Okay. But okay, this is the concept here. Okay. So here, what it will do when it comes to MR execution engine, for every job, okay, we'll have a separate application ID and separate application master and okay, separate mappers reducers. But when it comes to Tej Execution Engine, so whenever you run your first query, the session will start. Okay, you will have an application ID. This session will be up and running. Okay, this session will be up and running till till you stop submitting the new jobs actually. Okay, continuously for 5 minutes. If you don't submit any jobs, then this session will be closed automatically. Okay, otherwise this session will be up and running. Suppose if you are submitting the jobs continuously for 2-3 days, okay, yes, this session will be up and running for 2-3 days. Got it? Okay, so here since you are not using
Is there in CDP also?
of course it is there, sir, it is there, but the thing is that okay, Tej is good or bad?
Good only, sir.
Good only if you are running more number of small jobs, sir. Okay, what in case of if you are running a job, okay, with 1 lakh mappers, 2 lakh mappers, just imagine like that. Okay, if somebody submitted 10 jobs at a time, it means like one application master has to take care of 10 lakh mappers. Correct or not? Okay, so yeah. Okay, so Tej is good, very good. Okay, when you are running more number of small jobs. Okay, but MR execution is good. Okay, so when you are running more number of large jobs. Okay, when you are running more large jobs, okay, then okay, every job will have a separate application master. Then no issues at all. Correct or not? Every job will have separate application master. So for us, okay, we are free. Okay, no issues at all for us. Okay, but that's not the case. Okay, with Tej, you will have only one application master, and if you submit okay 10 jobs, okay, with each job with 1 lakh mappers, okay, probably okay that application master may not be
Is
able
there
to.
any way we can increase the number of application masters in Tej?
No, sir, no. You will have only one application master per session.
Got it.
Okay, if the session is completed, okay, again if you
Then it is bad only, sir. Yes, because see, we have some jobs which are continuously running.
yes.
So if new job is coming, same. So maybe it means what I am thinking. We are not running it by Tej.
Yeah. That's what, sir. Okay, if you are running small jobs, okay, then fine. Okay, more number of small jobs. Okay, then okay, for each small job, okay, we don't want to waste one application master. Then you can go with the Tej. Okay, but you are running very big jobs or large jobs, then okay, better to go with the MR execution only.
Sir, here a job by job it will work, sir. Here, Tej.
No, of course, yes. Okay, job by job, okay. The
So once
results are there.
finishing
Okay.
the first job,
No.
after
Okay.
that only second job will start, right?
It's not like that. Okay, suppose resources are available, yes, 2 jobs can run parallelly.
The same application master.
Yes.
So here also the same procedure, sir. RM will.
Of course, same.
decided.
Yes. RM will launch application master, but only one application master per session. Okay.
For the
Understand.
job itself, they mentioned the application master. How many application masters? But by default, it will take single application master here.
By default, no. See, for user, okay, there won't be any difference, sir. Okay, understand? For user, there won't be any difference. Okay, so user will submit the job. Okay.
Okay.
So one application master will launch. Okay, but okay, see, normally what will happen? Okay, if you see MR job, okay, you submit a job. First application master will start. Then okay, it will request for mappers. Mappers will start. Okay, and do their work. Save the output into local file system and close. Then reducers will start. Process the generate the final output. Okay, reducers will be released. Finally, application master also released. Yes or no?
Yes.
But when it comes to Tej, okay, the last application master will not be released. Okay, that application master will be still up and running.
Okay, when it will release, sir? After
when it will release, like if you don't submit any jobs continuously for 5 minutes, it will be released. There will be a timeout.
Okay.
Got
Sir,
it.
one question. Let us suppose if we have 3 edge nodes. So it will create three sessions and 3 application
3 users, 3 sessions, sir. Yes, sir. Sessions are based on user wise.
Okay, sir. Got it. Yeah.
Understand? If 3 people are there, okay, if Venkata and okay, Alan, okay, Vipin, okay, 3 people are executing their jobs. Okay, you will have your thesis session, I will have my thesis session, and okay, other Alan will have Alan's thesis session. It's not the same. And again, okay, from different machine, again different thesis session.
Sir, this cluster will have both TASE and MR engines, sir.
Yes, sir. Okay, you'll have both. Okay,
For large
jobs, okay, people will use a MR execution engine. Okay, for small jobs, they'll use TASE execution engine.
okay, sir. That means
Okay.
how can it
How can we change it? Okay,
identify-
yeah. You can change it like this, sir. So this is okay. You can set okay execution engine equal to high stage. Okay, so it means okay now stage is in. Okay, you can say Spark also like this Spark execution engine. Understood? So you have
Yes.
MR execution engine, okay. But MR it is saying that it is not supported here. That's okay. Because this version is not supporting MR execution engine. They removed the support for MR execution engine. The latest time. You don't have MR execution engine, you have only Tej execution engine or Spark execution engine. Okay, so now we'll go with the Tej execution engine. Clear?
Yes, sir.
Yeah. That's okay, you'll be taking it. Okay. So here, okay, Tej is an efficient execution engine, okay, faster than MR that built on top of YARN. Major advantages of over YARN are that okay, no intermediate data will be written to STFS and no time spent in queue to start the next MR job. Each day session comes up with the one application master that takes care of execution of all queries those were submitted in that session. Understood? Okay. So one good thing is that okay, so it will never store the temporary output in local file system. Okay, that's why okay, it is a bit faster compared to MR execution engine. But okay, the problem here is that okay, if you are using okay large queries, then you may see some performance issues definitely. Okay, you should give big application masters. Then only large queries can be taken care. Okay. So here, since application master is readily available to accept the new queries, smaller tasks can be started without wasting time in negotiating with the RM. Okay, understood. So this is the MR execution engine. Nothing much actually. So the next concept is Hive Server 2. What is this Hive Server 2, guys? What is Hive Server 2? Okay.
Sir, one
Nice,
question.
okay. Sir, tell me.
Can I job one job? Can I run Tej and MR execution
Both, sir. Okay. Different sessions.
at a time?
Okay. Sir, I'll tell you. Okay. So now, okay, I logged into Allen HN4, right?
Yes.
Huh?
Yes,
Allen HN. Okay. Now I will log into the same machine as Allen. Okay. Both sessions are same now. 5. See? I logged in. Okay. GPS. Now see, this is okay for first Allen H14. This is for second Allen H14. Understood? Okay. So in this prompt, okay, you use Tej. In this prompt, you use okay MR. Got it?
Okay.
Yeah. Okay. So now okay, I closed one. Okay.
So properties only will decide, set properties
Yes.
only will decide whether
Yes,
to
yes.
go for Tej or MR.
Yes, sir. Yes, sir. Yes. Sir. Okay. So the next one is okay Hive Server 2. Okay.
Usually, what property set in production servers?
It is the same
Yes, sir.
property, sir. It is the same property.
Okay, sir.
Okay.
So the 5 minutes and time interval where we can set, sir, where it is there. Okay. The default is 5 minutes, sir.
This session, okay.
Close.
6 and okay, 10 minutes here. It says 10 minutes. Okay. Earlier it was like 5 minutes, but now 10 minutes.
This is
Understood?
default time, sir.
Yeah. Yes. Okay. Okay. So the next one is Hive Server 2. What is this Hive Server 2, guys? What is this Hive Server 2? Okay. Let us take this scenario. Okay, guys, try to understand. Okay. Okay. Now, basically, so these are the Reliance Fresh stores. These are our 5 Reliance Fresh stores. Okay, so now, okay, so when customers make any transactions, okay, the customer transactional data will come and sit in the small databases, and using Scoop, okay, we are extracting this data into cluster which is running in Mumbai. Yes or no? Okay. So first it is coming like raw data. After that, you are storing into Hive, and okay, you are converting that into valid data, invalid data. Then okay, you are processing data. Then okay, you are storing into summary tables and okay, partition tables. Okay. So normally, who will use these summary tables? Who will use these summary tables? Management. Okay. Management means, so who want to see the sales? Okay, like okay, I want to see the top 10 cities in India. Okay, where sales are very good. Okay, I want to see. No, will end user? Will you see? Okay, which Reliance Fresh is doing good? Your end user, right? You cannot see. Okay, management. Who is the management? Reliance Fresh, Reliance management team, managers, Reliance managers. Okay, will see these summary tables. Okay, yes or no? Okay, but okay, partition tables. Partition tables means okay, so you are segregating your transactions into. Based on country, based on city, based on state, okay, like that, you are segregating your transactions. Okay. Normally, these partition tables will be accessed by users. Actually, users are customers. Understand, guys? Okay. If you want to say last 1 month transactions, okay. So what you will do, you will go to. Okay, suppose this is a bank banking cluster. Okay. So you want to see last 1 month transactions, what you will do? So you will go to, you will open a internet banking, and then you will log in with your user ID and password. Then okay, you will generate the statement, okay, account statement. Okay, this is starting and okay, start date and end date. Okay, so finally you will get your statement. Okay, so it means okay, you are retrieving individual transactions. Okay, so where these individual transactions will be stored? Individual transactions, partition tables only, right? Sir, what is the data in partition tables? We have partition by city and partition by country, right? Okay. I want to see, select a star from where city equal to, okay, Vijayawada. No, I'm not getting anything. Sorry. I got 10 records, or 10 records. Sir, no. These are all individual transactions, right? Yes or no?
Yes, sir.
Okay. But okay, will I get these transactions? Okay, if I show. Okay, is it the same data?
No,
Can you see the
different.
customers? This is a consolidated data, a summary data. Understood? Understood, guys?
Yes, sir.
Okay, so here I can see that okay, in UK, so or in okay, so here okay, Washington, okay, okay, WA, okay, US, okay, so for this state, okay, these are the sales. This is the summary data. Correct or not?
Sure.
This is the summary data. Okay. But if you want to see individual transaction tables, okay, you need to go to the partition table. So here, okay, whatever you see is individual transactions. Okay, that's the reason I'm telling you. Okay, normally summary tables will be used by management, and okay, partition table will be used by users or customers. Okay, now the question. Okay, so who are the management here? Let's say Ambani. Okay, so the cluster here. Okay, so Hadoop cluster is in Mumbai, and Ambani is in Delhi today, and he want to access the data. He want to see the data. Okay, what are the total sales? Okay, okay, what are the total sales across 2021 April and 2021 March and first quarter of 2021 and first quarter of 2022. Okay, you want to see this report. Okay, what he will do? Ambani is in Delhi now. How he can see his report, guys? Now tell me. How Ambani can see this report? Okay, let's say. So we have the data here. Okay, so we have 2022 March month data is here. Or 2022 Q1 data is here. 2021 Q1 data also here. Okay, in the Hadoop cluster. Okay, Hadoop cluster is in Mumbai, and this guy is in Delhi. He want to see the data. Okay, what he will do? Normally for Ambani, so he will access this kind of reports on using mobile application or iPad or internet website. Okay, so in his iPad, he will open the report, and he will click so Q1 2021 versus Q2 2022 and okay, submit. Okay, so what will happen now? In his iPad, he is doing this one. Okay, now his iPad will send the report to Mumbai cluster, Mumbai Hadoop cluster. Okay, now iPad is sending a report. Okay, now who is the receiver here? Who will receive your query? Huh? Who will receive your query? There should be some service, right? Why NameNode will receive Hive query? It is a Hive query. Okay, you want to see the sales. Okay, so it means okay, you want to access some data from summary tables. Understand? Why NameNode will accept this request? So to accept this outside request, okay, so we have one service which is called as Hive Server 2, which is continuously up and running. Okay, so this is kind of a web server here, guys. Understand? Okay, sir, very simple. Okay, let us try to understand. Okay, let us try to understand how this web server will work actually. Okay, web server or application will work. Okay, sir, okay, you all might have seen this HDFC. Okay, so some banking websites, right? Okay, let's say let us take any bank actually. Okay, so here Axis Bank, you take Axis Bank. Okay, so when you click on axisbank.com, okay, it is giving you login ID, use and password. Correct or not? Correct or not? Okay, how this website is working here, guys? How this website is working? So they might have hosted this website somewhere. Okay, it means okay, so they have taken a server here. This is the server. So this is called as hardware. This is hardware. Okay. On top of this server, okay, what they will do? Huh? On top of this server, okay, they will host the application. Okay. This is the application. Application means website. Application or website. Okay, what we website. Okay, so they hosted the website. Okay. So this is in server 1. Okay, so all together this is in Mumbai, let's say. All together this is in Mumbai. Okay, so now this is the server. In this server, okay, we have a website, okay, posted here. Okay, now, okay, so this is Venkata here. Venkata sitting in Bangalore. Okay, Bangalore, and he is opening his laptop. Okay, in his laptop, okay, so he is typing this website address is okay, www.axisbank.com. This is the website address. Okay, this is the website address that they have given. So he is opening this URL here. Okay, so what will happen now? How his request will reach Mumbai's so application hosted here. Tell me, guys.
There might be some secure network. You'll be connecting to the internet first, and then connecting to the secure network.
Okay, of course. Okay, you have internet here. Okay, this is the internet here. Okay, internet. Okay, so this is the internet here. Internet. Okay. Yes. Okay. You have internet access. Okay. So here, okay. Your laptop, when you open a Chrome, is sending the request to internet. Okay. How this internet is helping you to connect to this web application?
There will be his registered company portal, right? Like a virtual private network or something. Over there, he will be connecting to it. Then he will be into Axis Bank data center network or whatever you call it.
No. How internet is identifying this is the one? IP address. Sir. Even the IP address is there. Sir, I know your system. Okay, you tell me your system IP address. Okay, let's see whether I can connect to your IP address or not. Huh? Give me your IP address. Okay, let us try. Okay, whether I can connect to your IP address or not. It is not possible, sir. Okay, so in between, okay, you should have one middleware. This is called as middleware. What is middleware?
Web server, sir.
Kind of middleware is nothing but okay, so kind of web server. Okay. What is this web server? Which can expose your application to outside world internet. Understood, sir? Which can expose if this is not there, okay, there is no use of this internet website. Understood? Understood, guys? Okay. So this is the one. Okay. So now you take the same thing. So here this is your application. Okay. Plus one web server which will be able to expose your application to internet. Yes or no? Okay. In the same way, what I will do, in the place of application web server, I will say Hive. Okay. Now, if I have Hive here, using web server, can I expose Hive to internet or not? Huh? So, Hive plus web server, these two equal to Hive server.
Hive server.
You understood what is Hive server 2? Okay, actually the 2 is like, okay, earlier it was having Hive server. Now, okay, they have released the new version of Hive server, so they made it like Hive server 2. Okay, understand? Okay, so you got my point now. So if somebody want to connect to, okay, suppose, okay, now here, okay, so Venkata Bangalore lab, okay, you want to connect, you want to see the statement, okay, so you log in here and okay, he will submit the command here, okay. So I want to see last 1 month statement. Immediately that will be going to internet, from internet, okay, the request will reach here. So again, okay, in between, okay, you will have okay, public DNS, all those things will be there. Okay, that's a different story. But okay, from internet, okay, the request will come and hit okay, web server will forward the request to Hive. Hive will execute the query, send the result back to web server. Web server will send the result back to your laptop okay, over internet. Got it? This is the story. Okay. So here also for Hive also, okay, to expose, okay, if I have only Hive without web server, can it be exposed to external world?
No, sir.
I have only Hive. No, okay. Without web server, okay, you cannot expose the service or application, website, anything to external world. Understood? Okay. So now you take in this scenario. Now here we have Hive server 2, which is running in this cluster. Okay. So now what Ambani will do? When Ambani select the report in his iPad, immediately iPad will hand over the request to Hive server 2. Okay. Now Hive server 2 is a combination of Hive plus web server. Okay. So obviously the query will be received by Hive server 2 and execute on these tables and generate the report and send the result back to Ambani iPad. Now iPad will display it on the screen. Okay, so this is how external people will be able to connect to our cluster and access the data. You got my point? So this is how external people will be able to generate the report. Okay, see, you generate your statement, bank statement. For you, it is a bank statement. For Hadoop cluster people, for Hadoop admins or for Hadoop developers, it is a report. Understood?
Yes, sir.
Okay, so now the question is that where to install Hive server 2. So now this is our Hadoop cluster. Okay, this is our Hadoop cluster. Now where to install Hive server 2? You understood what is Hive server 2?
Yes, sir.
Correct.
Yes.
Okay, so now the question is that where to install Hive server 2?
Edge node.
Okay, so here can I install on Edge node? Okay, now the question is that yes, Edge node is the correct one. Okay. We'll be installing Hive server 2 in Edge node only, but the question is that is one Hive server 2 sufficient? Huh? Is one Hive server 2 sufficient? If it is a banking cluster, how many people will be connected to a cluster and accessing their data? How many people will be checking their account balance? You want to check your account balance, okay? How the information will come?
Lakhs of people.
Huh? So, okay, you want to check, okay, so let's say, you have your PhonePe app, okay? From PhonePe app, okay, you are checking your account balance. Okay, so it will come here, okay, then it will reach here, okay, obviously, I will get your account data, your account balance and send your balance back to your app, or the app will display on the screen. Okay, so suppose, okay, it means, okay, so daily millions and billions of people will be accessing their accounts and checking their account balances, downloading their account statements. Okay, they'll be doing many things actually. Okay, so for one Hive server 2, is it sufficient for those many people? Huh?
May not, sir.
Definitely one Hive server 2 is not sufficient here. So what to do? That's the reason we will go with the multiple Hive server 2s. Okay. How many Hive server 2s we can go? Is there a limit for number of Hive server 2s? There is no limit. Okay, you can go. So we have total 17 Hive server 2s we have in our cluster. Understood? You may ask, sir, why so many? Because so many customers are accessing our cluster. So one Hive server is not sufficient. Initially, we kept 2 Hive server 2s. So load is too much. And then we made it 5. Okay, then 7. Okay, 8, 10. Okay, today, as of today, we have 17 Hive server 2s. Okay, so now the question is that, okay, sir, if 17 Hive server 2s are there, how they work together? Okay, how okay, this system, okay, so how your iPad or laptop will understand, okay, I need to submit to this Hive server 2 only. So here all 17 Hive server 2s, okay. So here, okay, HS2, okay. What's Hive server 2? Okay, let's IP address is 192.168.56. Okay, Hive server 2. Server 2 IP address is 168.56.120. Okay, or let's say 161. This is the IP address. Okay, like this. Okay, every Hive server 2 will have separate IP address. Or not. Okay, like this, okay, you have 17 Hive server 2s, 17 Hive server 2s, but all these 17 Hive server 2s are okay, combined with the load balancer. It's just to load balancer.
Sir, how I server to sir? No, which job is?
I'll tell you, sir. I'll tell you. Okay, load balancer here. Okay. Maybe my load balancer is okay. Okay. The load balancer IP. Okay. So all the requests. Okay. So here, okay, customer one. Okay. So customer, okay, 1 million. All customer request, so will come and hit. Any customer request will come and hit, okay, the same IP, same load balancer IP. What is this load balancer, guys?
Load will be distributed.
Okay, so all customers request will come and hit this IP address. Okay, so now this load balancer will understand, okay, which Hive server 2 is free and hand over the query to that Hive server 2. Understood? Okay. It will check whoever is free. Okay. It will hand over to that Hive server 2. Understood? Or any questions? So end of the day, you need result. Okay. Which Hive is executing doesn't correct or not? So it is the responsibility of. Whose responsibility it is? It is the responsibility of Hive server 2 to execute the query. But okay, so your query will go to which Hive server 2? Okay, you no need to know. Okay, so maybe customer 1. Okay, he is trying to take his balance, okay, from laptop. Okay, customer 2 mobile. Okay. Customer 3 keypad. Okay, customer 4 okay, ATM. Okay, whatever is the way. Enough that the request will come and hit here. Okay, and these are the ones who will execute the query and okay, send the result back to the customers. Okay, now okay, you may ask a question. Okay, sir, okay, how it will understand which customer? Every customer, okay, will okay, every query submitted by a customer will have a separate query ID and session ID. Based on that, it will identify, okay, which customer, which session ID. So it will send the result back to correct customer and correct query ID. Understood? So no need to worry about, okay, whether, okay, if I submit a query, okay, my result will go to somebody else, some other customer. No. Okay. So that complete security mechanism is clearly implemented in Hive. You got my point? Or any questions?
Sir, this load balancer, is it a service or a separate?
So load balancer case is again, you can say it is a service only, sir. Okay, network people will manage this load balancer, right?
Where it is there, sir, including?
Network people will maintain, sir. Okay.
It's not like the edge node.
No.
Sir, can we specify which all host this Hive server 2?
Sir, while creating this while configuring this load balancer, you need to specify all the IP addresses. Got it? You need to specify all the IP addresses, okay, while configuring the load balancer.
No, sir, but my question is, we installed our Hive, yes.
Okay.
How do you know where our Hive server 2 is running? Is it running in all the Hive clients?
No, sir. Okay, so like this, okay, we have 21 edge nodes, sir.
Okay, sir.
In our cluster, we have 21 edge nodes.
Mm-hmm.
In 21 edge nodes, okay, 7 edge nodes, okay, we are running Hive, 17 edge nodes, okay, we are running Hive server 2.
Okay.
Got it?
The Hive server 2 only, the load balancer will be there, sir. Separate.
Sorry?
Yeah, load balancer.
Sir, okay, load balancer, okay, you need to create, okay, at the network level. This is not Hive level. Okay, just okay. If you want more information about this one, okay, just okay, check for a load balancer.
Sir, one question. See, let us suppose we installed HN1, HN2, HN3, HN4. We mentioned only 3 and 4. We need to run Hive client. Correct. So how means an admin knows that.
Sir, okay, admin who will be starting the services here? Sir, okay, now I will show you the cluster. Okay, this is our Hadoop cluster, correct? Click on here. Okay, where Hive server 2 is running?
Oh, 2.
Which machine? Click on this one.
Yeah.
Which machine?
HN2, yes.
HN2, okay. Let's say, okay, you want one more Hive server 2. Okay, actions, add Hive server 2. Okay, in which machine? HN1.
Okay,
confirm.
sir.
Okay, so like this, okay, then okay, you'll have one more Hive server 2 here. Okay, got it?
Got it, sir. Yeah, got it.
So like this, okay, you can install, okay, so you can see all 21 edge nodes, okay, all 21 edge nodes, okay, I selected 17 edge nodes and I added one Hive server 2.
Is all Hive server to connected to load balancer, right?
Yes, sir. All Hive server 2s are connected to load balancer. Yes. Okay. Why okay load balancer concept is here? Because okay, see, this customer doesn't know how many Hive server 2s we have. And okay, which Hive server 2? Suppose okay, if customer 1 is always sending to 161 Hive server 2, then okay, you will always send there only, right? If that is not working, customer 1 query will not work. Instead of that one, okay, so I will add, okay, like this, okay, so whichever is okay, let load balancer decide, okay, whoever is, which Hive server is free, and okay, and submit the query there. Got it? Huh?
Okay. So any limitation of the number of Hive server 2?
Sir, if number of Hive server 2s are increasing, is it a limitation or an advantage?
No, advantage. I must maximum.
No maximum numbers. No maximum number. Understood.
Depending on the load and the customer request.
If you require, okay, so if yours is okay, world number 1 bank and okay, you have okay, billions and trillions of customers, okay, yes, okay, then okay, you may require 500 Hive server 2s also because of the load. Understood? Yeah. Okay, it purely depends on how many queries are running. Okay. Suppose, okay, sir, okay, let us take this scenario. One Hive server 2 is able to handle, okay, 100 queries at a time. Okay. So now I have 17. Okay, it means, okay, 1700 queries at a time, okay, we can handle. What in case, okay, there are, okay, 2000 queries are coming at a time? You may have to increase number of Hive server 2s, correct? Yes or no?
Yes, sir.
With the existing capacity, I can run only 1700 queries at a time. But okay, 2000 queries are coming, incoming queries at a time. Then, sir, okay, I don't know when you are checking and you don't know when others are checking. Okay, so there is a possibility that okay, 2000 people may check there. Okay, so let us check, okay, during okay salary time. Okay, so let's check March 31st. How many people might have checked your account balance? Okay, multiple times, whether I get salary or not. Correct, right? Huh? Yes or no?
Sir, Hive server 2 maintain only the customer's login information, right? All the Hive server.
Of course, sir. Of course, yes. Okay. I guess we have spent enough time on this. Okay, so server 2 is a server interface of Hive that enables remote clients to submit and execute queries against Hive and retrieve the result. Okay, so if any external people who doesn't have access to Hadoop cluster, okay, normally customers and management people, they will not be having direct access to Hadoop cluster. Okay, if anybody want to access the data which is stored in Hive cluster, sorry, in a Hadoop cluster through Hive. Okay, so they can connect to Hive server 2 and they can retrieve the data. Okay, so Hive clients like Beeline, Squirrel, and external web applications can connect to Hive server 2 through Thrift and submit their queries. Okay, so here if you see the components of Hive server 2, so you have something called a Thrift service. Okay, so if you take entire Hive server 2 as a home, okay, as a house, Thrift service is the entry point. Okay, main door. Okay, so all the clients, okay, when anybody submit any query, okay, so I'm saying, okay, it will come and hit Hive server 2. Inside Hive server 2, it will come and hit the main door. Main door is nothing but Thrift service. Okay, so now for every query you have a session ID. You'll have a separate session ID. Okay, so based on the session ID, okay, it will first, okay, so it will check the accept the query and do the syntax check. Okay, so if everything is fine, okay, so then it will compile and do the syntax check, and finally execute is the one who will execute the query. Okay, any questions? So Hive server 2 supports multi-client concurrency, LDAP, Kerberos authentication, Sentry authorization, SSL encryption, and provides better support for JDBC, ODBC clients. Okay, Hive server 2 supports multi-client concurrency. So multiple people can connect to Hive server 2 at a time. First thing. Second thing, it will support authentication, LDAP, Kerberos authentication. Okay, it means, okay, it supports complete security. Okay, without proper valid user ID and password, you cannot connect to Hive server 2. Okay, and again, without proper authorization on the tables. Okay, so without proper access on the tables, you cannot access the data from the tables. Whatever table you want to access data, it is not possible. Okay, you should have permissions on the tables, then only, okay, you can access the data. Okay, complete security is implemented on Hive server 2. So even if multiple external customers connect to Hive server 2 also, then they can access only their data. They cannot access others' data. That's how the security is implemented. Clear? Okay.
And this is only limited to Hive related queries, right?
Yes, sir. Yes, sir. Yes, sir. Only Hive related queries, it is limited.
Could you please explain the Thrift server, sir?
So Thrift server is a main door, sir.
Okay.
Okay, it's a main door. It's an entry point for Hive server 2.
Okay.
Got it? Got it? So if you want to enter into house, okay, you should have main door, right?
Yes, correct, sir.
Thrift service is kind of a main door for us, for Hive server 2. So Thrift, okay, Hive server 2 means, okay, Hive server 2 means, okay, so it contains multiple parts, small parts. Okay, that one of the part is Thrift server, which will allow external clients to access, submit their queries.
Okay. Here session 1 and session 2 means
each query is session 1, session
2. Okay, fine.
Clear?
Yes, sir.
Okay. So the next one is Hive Metastore. What is this Hive Metastore, sir? Hive Metastore is the central in-memory repository for Hive data. Okay. So let us take this scenario, sir. Okay, let us take this scenario. Okay. Okay, so let's say this is your edge node. Hive is installed here. Okay, Hive is installed here. And okay, so if any Hive command you submit, okay, let's say select star from sales data table. This is the command, okay, you submitted. Okay, so what will happen? If you run this command, what will happen, sir? What Hive will do first? What Hive will do? Hive will connect to Metastore DB, backend RDBMS, and check whether this table is available, table metadata is available or not. Okay. So, okay, table metadata is available or not. If table metadata is available, then it will check, okay, what is the actual data path of this table. Then, okay, it will take the actual data path, then go to SDFS and access the actual data. Correct or not? So it means, okay, for every query you run, Hive is contacting metadata. Without contacting metadata, can Hive run their query? Its query. So without metadata, okay, Hive cannot understand where is actual data, and okay, so it cannot run any queries. So metadata is a mandatory one and must one. Okay, first point of contact is metadata. Okay, so now let us take this one. Okay, so this metadata, okay, what database we are using in our environment, in our cluster? MySQL we are using. Okay, and what are the maximum connections for this MySQL we have given? 500 connections. Okay, but okay, what in case if 2000 people are submitting queries, sir? For each query, it has to connect to, it has to check the metadata are not required.
Required, sir.
Every query, okay, so you run any query, okay, it has to check, okay, it has to connect first. Okay, the first checking is first, okay, when you submit a query, that will be given to Hive. So what Hive will do, Hive will check in the backend RDBMS, okay, for metadata. Okay, so after taking checking the metadata, after taking the actual data path from the metadata, then only it will go to SDFS and get the actual data. Correct or not? Okay, so if 200 queries are submitted, okay, parallelly, okay, so it means, okay, 2000 queries are submitted parallelly. It means, okay, 2000 connections should be made to Hive backend DB. But how many connections, maximum connections it will allow?
500.
But what about remaining 1500?
They need to wait for that.
So they'll be in waiting state. Otherwise, okay, if the waiting time is more and more, okay, then okay, they'll be, those queries will be cancelled automatically. Correct or not? So don't you think that, okay, accessing metadata every time, okay, from this RDBMS will take a lot of time?
Yes, sir.
Okay, again, okay, accessing this data means, okay, so this data, this RDBMS is installed, I mean, installed in a system, and it is storing that RDBMS, I mean, this RDBMS is storing the metadata in the disk actually. So it means, okay, every time you are reading from the disk. Okay, so when more and more queries are getting submitted, okay, definitely the single metastore database, okay, cannot help Hive, okay, in providing the metadata. Okay, so that is the reason. Okay, so what we are doing, okay, so what Hive is doing, Hive is coming up with a different concept here. Try to understand, sir. Hive is coming up with a different concept here. Okay. Okay. What is the different concept here? Huh? So here, what Hive is doing, Hive is coming up like, okay, a new service here, guys. What is that new service? Hive Metastore service. There is a difference between Hive Metastore DB and Metastore service, guys. Okay, Hive Metastore DB means it is a backend RDBMS. Okay, so Hive Metastore service means it is a service, okay, where you will have in-memory metadata. Understood, sir? Understood? See, here Hive is not directly connected to backend RDBMS. In between, we are introducing one service here. What is the service? Okay, Hive Metastore service. What this service will do? This service will hold the Hive metadata in memory. Okay, when it is in memory, okay, the reply time will be faster, right? And more connections can be made to this service, right? Huh? Yes or no? Okay. Now again, okay, so here I'm going like a load balancer here. I'm going like a load balancer. Okay. So I may have any number of Hive Metastore services. Okay. Tomorrow, okay, if I feel that, okay, so many queries are coming, okay, okay, you take that, okay, each Metastore is able to handle only 500 queries. Then, okay, I will put, okay, 4 or 5 Hive Metastore services, so that, okay, 2000 queries can be handled parallelly. Got it? So this is only for metadata, guys. This is only for metadata. Okay. Now you see here. Okay. If you see our cluster, okay, there is something called Hive Metastore. What is this Hive Metastore? Hive Metastore is running like a service here. Okay. So started. What is this started? It is a service, guys. Okay. So, and if you want to add more and more Hive Metastores, you can click on add Hive Metastore. You can have multiple Metastores also. Are you clear? Huh?
So basically, to improve performance, we can
performance of yes. Okay. See, then improving performance. Yes. Okay. Performance improvement is fine. Okay. Okay. Otherwise, okay. So this is creating a lot of load on backend RDBMS, right? Yes or no? Is it creating too much load or not? It is creating too much load on backend RDBMS. Okay. To reduce the load on backend RDBMS. Okay. So we are coming up with a Metastore as a service concept. Okay. See here. Okay. We need to understand Hive Metastore DB. Hive Metastore DB, which is nothing but okay, MySQL database. Okay. MySQL RDBMS. Yes or no? Okay. Which stores the data in disk. Okay. Hive Metastore service. Okay. This is not a RDBMS. Okay. Copy of. Okay. In memory copy of. Okay. MySQL RDBMS. Okay. This comes from RAM. This is disk. This is RAM. Understood? Understood or not?
So you have to first contact to Hive Metastore service.
Okay. So first of all, okay. So what Hive Metastore services will do, whenever you start this service, it will take a copy of this Metastore database. Okay. Metastore database and they put it here. Complete Hive metadata will be in memory now. Okay. Now, whenever you run a query, Hive will not directly connect to RDBMS. I will connect to Metastore service. Okay. From in-memory Metastore, it will get its required metadata and then connect to actual data. No direct interaction between your Hive and okay, Hive Metastore DB. So your Hive will be connected to Hive Metastore service. Understood? Are any questions? Huh? Okay. So now, okay, this is okay. So what is Hive Metastore? Hive Metastore is the central in-memory repository for Hive metadata. By default, Metastore run a same process Hive service. Using this service, it is possible to run Metastore as a standard process to serve all its clients effectively. See here, there are so many people who are trying to access Hive metadata. Okay, if all try to connect to Hive backend metadata database, then okay, there is a high load on this RDBMS. To avoid the load or to reduce the load on RDBMS, so whatever is there in this RDBMS, we are maintaining the same copy of metadata in the Metastore service. Okay, so let all the clients connect to Metastore service and get the data. So if you are accessing data from metadata from RAM, it will be super duper faster compared to this.
For suppose if the metadata size is 1 GB, so the same 1 GB data will maintain the service as well.
Exactly, sir. Yes. That 1 GB will be in memory of Metastore service.
Yeah. So how many meta services are there? So they will maintain all.
Yes. Each one copy of Metastore. Okay. Yeah. So this is the real-time implementation, guys. Okay. So here, okay, this is the Metastore DB, which will have high availability. MySQL will have high availability. Okay. So here you have Metastore service. Okay, and Metastore service load balancer. Okay. And here Hive server 2 load balancer. Okay. So if somebody submit a command, okay, let's say somebody submit a command, okay, using internet banking, because somebody submitted a command. So your internet or your Chrome will hand out the request to Hive server to LB. This LB will see who is free. Okay, and hand over the command to that Hive server 2. Okay, let's say this first one is free. Okay, it handed over the command to first Hive server 2. Okay, now first Hive server 2 will check in the, okay, will require metadata. So what it will do, it will hand over the, it will connect to Metastore service LB. Now out of these three, whichever is free, that one will provide the metadata for Hive server 2. So now Hive server 2 has got the metadata. With that metadata, Hive server 2 will connect to HDFS and get the data, actual data. Got it. So Metastore services are the ones who will just provide the metadata of your query. Got it.
One question, Venkat.
Yes, sir.
This Metastore service, multiple services, and Hive server 2, multiple services, all will run in the same machine. In the sense, it's in HAM only. Yes, means kind of.
Sir. Okay. Now where Hive Metastore service will run? Great. Okay. Where Metastore DB is running? Metastore DB is this
HAM. Yes, sir. Yes.
Okay. These are Metastore services.
Okay, sir.
Understood. These are Metastore services.
Okay, this can run on any node.
Yes. So this service, what this service will do, whenever this service is started, this will contact this DB, and whatever is there in this DB, it will get that and put one copy here. So this Metastore service will have continuous connection with this one. Whenever a new metadata, whenever metadata changes happen here, immediately it will take a new copy here. Got it?
Got it, sir. Got it.
Yeah.
And the same applies to that server also, Hive server 2 also?
Of course, yes.
So it will also run on
any
edge node, yes.
Any edge nodes, yes. Okay, so now what will happen? Okay, suppose if somebody submit a job, okay, okay, that will come. Okay, that query will come and hit boom server 2. Okay, so where Hive server 2 will check metadata. Will check in Hive Metastore or Hive Metastore DB?
Hive Metastore service.
Okay, it will check in the Hive Metastore. Okay, it will understand. Okay, so from this Metastore service, it will understand where the data is available. Correct or not? Where the actual data location is available. With this actual data, it will connect to this Hadoop cluster.
Okay, sir. Got it.
Got it. Got it? Or any questions? Sir, I am not teaching only Vipin or Bharani, sir. I am teaching others also. You can open your mouth and talk. Got it? So if Alan submit a query, okay, Alan submit a query that will hit a Hive server 2. First, what Hive server 2? This, okay, first step. Okay, this is step 1. Step 1. This is step 2. Understood? Understood or any questions? Step 2 is connecting to this one.
HDFS.
Yes. Okay, that is okay. Now connected in real time. This is how they will set up page. Okay. In our environment, okay, we have six Hive Metastore services. Okay, 6 Hive Metastore services, and Metastore DB. Okay, only one, but that has high availability. Okay, clear. And okay, these 6 Metastore services are accessed by using Metastore service LB, and 6 Hive server 2s are accessed by Hive server 2 LB. Clear? Okay. So now let us talk about Hive architecture. We have seen many things in Hive. Okay. Let us talk about Hive architecture now. When I say Hive architecture, when you install Hive, what and all will be installed? Okay. When you install normally Hive, okay, it will install JDBC and ODBC drivers by default. Okay, but not all ODBC drivers can be used to connect to different sources. But okay, you may have to install new ODBC drivers along with you. But okay, Hive is the one which will support JDBC clients and ODBC clients. Okay, then command line interface. You know what is command line interface? Okay, you can use Hive in the command line also. So suppose if you have access to Edge node, you are an employee of the company. You are sitting and working in Mumbai. Okay, you are sitting in Mumbai and working in your cluster on your cluster. So if you have direct access to your Edge node, okay, you can connect to Hive using command line interface, CLI. Okay, web interface. What is this web interface? What is this web interface, guys? Okay,
is our UI.
Okay, so here they closed. Okay, so you can. Okay, so actually, there was something called Hive View, guys. Actually, okay, so you can submit your queries. Okay, tomorrow I will show you what is this web UI. Okay, so you can submit your queries in the UI. Okay, kind of. Okay, you know that. Okay, for Oracle we have Toad. What is Toad? It's a kind of UI where client UI, where you submit a query here, and the query will be given to RDBMS, and okay, it will execute. Okay, so here also it is the same case. Okay, so it will come with the web service, web interface also. Okay, and Thrift server. You know where is the Thrift server? So when it's the Thrift server, it is the entry point for your external queries, actually. Hive server too. Okay, so then Metastore. Metastore means, okay, so again here Metastore, we have two things: Metastore DB, Metastore as a service. Correct, Metastore service. So DB means backend RDBMS, service means it's a web service, okay, which maintains the in-memory copy of Hive metadata. Okay, then driver. Okay, driver will do three things. Okay, compiler, optimizer, and executor. So compiler is the one which will compile your query. Okay, and optimizer is the one which will create a best execution plan for your query, and executor is the one who will execute your query. Understood?
Yes.
Yeah. Okay, so these are the different parts in Hive. Okay, you know, okay, about each and everything now. Clear? Okay. So these.
What is the role of this JDBC, ODBC? This will support, means any client can connect via these.
Yes, sir. This drive, JDBC, ODBC drive. Connection. Okay.
What is JDBC, ODBC? Simple example can explain.
So okay, let's say, okay. So you take Axis Bank. Okay, what is this, sir? Normally using what? Okay, what technology they use to design this web page?
Maybe Java.NET.
Java, correct? Okay. So yeah, no. If this application is designed using Java, okay, so then okay, Java applications will connect to Hive using JDBC drivers.
Oh, okay.
Got it. Okay. Yeah, ODBC drivers.
Okay, sir. Okay.
Okay. So I've given a simple. I mean, what is JDBC, ODBC? Okay, I've given information here. Then okay. See, whatever we understood till now, guys. Whatever we understood. Okay. Where is the admin work? We understood what is Hive. Okay, so what developers will do in Hive. Okay, so they get the raw data, store it to staging table. Okay, then okay, they separate valid data, invalid data. Then okay, from there okay, they what to say, valid data, invalid data. From there okay, they will transform the data. Then they will process the data. Finally, they summarize the data. And finally, they load into partition tables. They load into summary tables. All these things. Okay, who will do? Developers or admins? Huh? It's a developer's work. Okay. But what is admin work here? Admin work is like setting up Hive. Okay. And checking number of connections. How many connections are coming? Whether existing Hive server 2 are sufficient to connect to handle the load. If not, adding one Hive server 2 is your responsibility. Got it? Adding one Hive server 2 is your responsibility. Okay. So then
adding a server service also.
Hive Metastore service also your responsibility. Okay. LB load balancer configuration. Modifying the load balancer configuration also your responsibility. Okay. Apart from that, sir, what will happen if Hive server 2 is down? What will happen if Hive server 2 is down?
There is no interconnection with end users.
Okay. All end users will get impacted. Correct?
Yes.
Yes.
All end users, not even one. Okay. Everyone in the world. Okay. So whoever is accessing that banking cluster. Okay. So they will get impacted. Okay. So, but nowadays, are you seeing such scenarios? Okay. Have you ever seen that a banking website is down?
No, sir.
Why?
Sometimes.
But very rare, right?
Yes, sir.
Yeah, very rare. Okay. But 4 or 5 years back, it was the different case actually. You used to see, banking sites down for quite some time. Okay. But nowadays we are not seeing because they are using multiple services in one place. Okay. So if Hive server 2 is down, all end users will be impacted. Okay. So you need to be very careful on the end user facing, customer facing tools. These are called as customer facing tools, guys. What do you mean of customer facing tool? Will never face customer. If any customer submit a query, will it directly come and hit name node?
No, sir.
No, sir.
When any customer submit a query, will directly come and hit resource manager?
No, sir.
No. Okay. For customers, only entry point is Hive server 2. Correct or not?
Yes.
If Hive server 2 is down, all customers will be impacted. That is the reason we need to take care of this client facing or customer facing tools effectively. Understand? If they are down, you will get many people will be calling you and asking unable to open this or unable to access the data. Okay. So it is your responsibility to make sure. That the services, Hive related services, let it be Hive server 2 or Hive Metastore services, all these services are up and running without any issues. Okay. So the next one is statistics in Hive. Okay. Mostly,
If the thrift service also is down, then we can say that HS2 service is down.
Of course, yes. If main door is closed, can you enter into that house?
Okay.
Yeah.
Sir, how do we know that we need to add one more Hive service?
You need to understand the load, sir. Load.
Okay, sir. It will tell.
Sir, you will have right number of connections. Okay. Now let us do one thing. Okay. So now,
sir, if load is full means we received any ticket, sir?
Of course, yes. Okay. So, sir, let's go to Grafana. Okay. So here, let's go to Hive. Hive server 2. Okay. This will give you the charts. Okay. This will give you last 20. Okay. No data points. Get all databases. Okay. Memory utilization. Okay. Understand? Okay. Threads. How many threads are coming? Okay. So these charts will give you information like how many are coming. Understood?
Okay, sir. Yeah, I got it.
Okay. So using these charts, you will understand how many whether I need to increase number of servers or not.
We need to monitor the Grafana as well, sir.
Of course, yes. Grafana is the one for us, for admins. Got it? Okay. So statistics in Hive. What are the statistics, guys? Statistics means numbers about your tables. What do you mean of numbers your tables? Statistics such as number of rows of a table or partitions and histograms of interesting columns. Okay. So suppose, okay, let's say I have, okay, okay, so 100 million records in a table. 100 million records in a table. Okay. So now I'm running a query, select star, count star from table. How much time it will take? Huh? It will take some time, yes or no, to count 100 million records. But finally it will give me a number 100 million. Okay. If I run the second time same query, so first time it has taken, okay, 15 minutes. Second time also it will take 15 minutes, okay, and give me the same output. Third time also it will take the same 15 minutes and it will give me the output. Okay. So it means, okay, there are some queries, okay, which we are running continuously. Okay, where, okay, they may get, okay, where you may get same output. Okay. So now the thing is that, okay, when you know that, okay, many times if you run select count star, okay, why can't you get that information readily available and put it in RDBMS? Huh? So tomorrow, okay, when I say select count star, I don't want to count the actual data. Okay. So that already, okay, there is a thread, backend thread, okay, which counted all these things and, okay, put it in RDBMS. Immediately it will give me the output. Okay. We'll see with some examples here. What are the statistics? Okay. Compute table statistics. Okay. Okay. Analyze table. Okay. Compute statistics. Okay. When you run this statistics, okay, when you run this command, okay, so it is done. Okay. What it will do? Okay. So DSC. Okay. Okay. Now I'm computing statistics for transaction ID. Okay. Transaction ID for columns transaction ID. Okay. So what it will do? Okay. It will maintain information like, okay, in this transaction ID column, okay, how many unique values are there? How many total transaction IDs are there? In that, how many null values are there? All it count and it will store into backend RDBMS. Okay. Tomorrow, let's say describe extended. So can you see here what it is saying? When it's a describe extend, okay, formatted, okay, and if I give the transaction ID, it is telling that, okay, this is the column transaction ID, data type is this one. So minimum, okay, 1, maximum, minimum transaction ID is 1, maximum transaction ID is 4003. Okay, total distinct count is 3949. Okay, average, okay, column length. Okay, so then, okay, maximum column length, number of truths, number of false, okay, bit vector, comments. Okay, see here, all these numbers. Okay, so now here, okay, what is the distinct count we have? Huh? 3949. Okay, now if I say select count star from this table, okay, automatically it will give me, okay, 3949 without counting other original data. Okay, otherwise, okay, let us see the country. I'm taking the statistics on country. Okay, now you see country. Okay, so for country it is a string. Okay, minimum, maximum, no, null values. Okay, no null values. Distinct count. Okay, how many unique countries we have? 3. Okay, now if I say, okay, so if I say, okay, select distinct, okay, country. Okay. Okay. See how fast it is. Huh? Because it is not running the query on actual data. It is directly taking the data from pre-calculated data. Understood? Pre-calculated data. Okay. Got it? Okay. Like this, okay. So if you state, okay. So what are the statistics on state? How many different states we have? Okay. So here, okay, 58 different states we have. Okay. Average column length. Okay. Maximum column length. Okay. So, okay. How many nulls we have? 0 nulls we have. Okay. So these are the different numbers actually. When you run this query, it will be very fast because it is not taking from the actual data. It is taking from the stats. Okay, if you want to see how many nulls we have, select okay. Select star. Okay. Process new where state equal to null. Immediately it will give you. It is very fast because it is already pre-calculated all the stats and it will give you that information.
So for actual data, any modifications it will update?
No. It is not doing any modifications on actual data. Okay? It is collecting all these numbers and storing it readily. Got it? Okay, so those are all about stats, guys. Stats are very important. Okay, yeah.
Where is it storing this data?
Where this stats data is getting stored in a backend RDBMS. Hive Metastore DB. Got it?
Okay.
It's metadata only.
Sorry?
It's metadata only, sir.
It's a metadata only, right?
Okay.
How many null values we have in a table? Okay. How many distinct values we have in a table, in a column? Okay. It's a metadata only, right?
Yes. It will contact to HDFS only for actual data.
Yes. Okay. So it will so if you enable the statistics on a table or a column, okay, what it will do, Hive, okay, the background, okay. So it will
predefined outputs.
No. Whenever you insert some data, automatically it will calculate the count of the data, number of rows, count of rows, okay, and it will store that count of rows in backend RDBMS. If somebody asks a select count star, it will not read the actual data. It will give directly this number.
Okay.
So that your query execution time will be very fast. Got it?
Okay, sir.
Yeah. So if you want to know what is the total size of your table, how can you say what is the total size of the table? Huh?
Yes, sir. Only information about the file it will display.
Exactly. So describe. Okay. Describe formatted. Okay. Or if you want to see the total, describe extended. Okay. If you use describe extended, it will give you total size of the table. Describe extended. Okay. So here, okay, all are true. Okay, it means okay. So so here you can see what is the total size. Okay. Number of files. Only one file is there in this table. Okay. So what is the total size of this create? This is the created time. Okay. Last extension. Total size. Can you see? Huh? Number of rows. Okay. Raw data size. Okay. Understood. It will calculate all these things before itself and keep it readily available. Got it? Okay. Now, okay, where or when to use Hive? Okay, normally, where you will be using Hive or when you will be using Hive. Hive should be used to store and process structured data only. Okay, so if you want to store and process structured data, then only you will use Hive. Okay, Hive is not used for unstructured data or semi-structured data. Okay, Hive is used only for structured data. Okay, Hive should be used for analytical querying of data collected over a period of time. For example, to know the sales trend for last 5 years. Okay, normally Hive will be used to generate reports over a period of time. Okay. Hive is used to generate reports. Okay, on data collected over a period of time. Okay, let's say I have data for last 10 years. I want to know. Okay, so how are the sales? Okay, every year. Year 1, how are the sales? Okay, year 2. Okay, so if you have some already existing data and you want to run some queries on top of that data, in such scenarios, okay, we will be using Hive. Okay, and data summarization and ad hoc querying. You know what is data summarization now? Okay, and ad hoc querying. Ad hoc querying. There are no. We don't know when queries will come. Ad hoc, on demand. So do you know when I generate my account statement next time? I don't know. But whenever I want, I can generate. That is ad hoc report. No pre-planned report. Okay, so you can run ad hoc querying. So when you have static data, normally, okay, when you have static data, but now Hive is supporting even dynamic data also, right? With Hive, okay, transactional tables, okay, you can modify the data on Hive. Okay, so you can. But Hive is majorly meant for static data. But now, okay, with the transactional tables, okay, you can use Hive for dynamic data also. Yeah, Hive is not really meant for real-time reporting purpose. Okay, no live reports at all. Okay, so you run a query at that time, whatever data is there, okay, on that data it will give you the output. But okay, no live reporting. It's only OLAP, not OLT. Got it? Okay, so the next one is performance tuning in Hive. Okay, what even a performance tuning in Hive is?
Sir, I have one question with
yes, sir.
Yes, sir. So is there any place where we can see if there are any statistics missing for Hive for the job submitted by users or developers?
Sir, those are different. Okay, those statistics are different. Those statistics are you can see in counters.
Okay.
Got it.
So
Hive statistics means Hive statistics are, okay, tell me.
Yeah, go ahead, sir. Go ahead.
Hive statistics are generated by Hive. Okay, and okay, job statistics are generated by application master.
Oh, got it.
Okay. Sir, the Hive statistics is default enabled, sir.
No, default is not enabled. You need to tell, okay, for which tables, okay, what stats you need to generate. Got it.
I have a question, sir.
Yes, please.
ఇప్పుడు హైవ్ స్టాక్స్ మీద రన్ అవుతుంది. ఇంతకుముందు మనం ప్రీవియస్ క్లాస్ లో డిస్కస్ చేసాం. ఈ కాంపాక్ట్, పార్టిషన్, బకెటింగ్. సో వాటి మీద డిపెండ్ అవుతుంది సార్ ఇది స్టాక్స్ అనేది?
అవును.
Okay.
How many partitions we have? Okay, in each partition, how many rows we have? How many files we have in this table? What is the size of the data? Okay, understand? Okay, so these are the table and partition level statistics, and column level statistics means how many distinct values we have, how many number of nulls we have, what is the maximum size we have, average size of the column. Okay, so these are the stats about particular column. Got it? Any questions? Okay. So performance tuning in Hive. Okay, what do you mean performance tuning in Hive? So if you want to see the best performance in Hive, okay, you should use partitions or buckets or indexes to avoid full table scan. Okay, so this is the mandatory point which every developer should follow. Okay, suppose okay, if there's a developer who is directly dumping the data without creating partitions, obviously when anybody run a query on top of the table, okay, it will scan all the data and give you the report. Okay, so you cannot avoid full table scans. Got it? Got it, guys? Okay, so you need to use partitions, buckets, indexes. Okay, that will improve the query performance. Okay, the next one is enable query optimization. Okay, what is this query optimization? Okay, So don't ask me what are these two properties, guys. Okay. So, but okay, these two I'm using from day one, but I never try to understand what are these two also. Okay. So high auto convert join and optimized queue join. These are the two parameters, okay, which we put, okay, if you are using joins actually. Okay, this will, if you're using joins, okay, then okay, this will improve the query performance. Okay. The next was set high VXCC parallel equal to true. What is this parallel equal to true? Okay. Enable parallel execution. Okay, guys, I'll give you one simple example. Okay. 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 So let's say I'm running a query. Select star from table. From A. Okay. Where? Okay. Subquery on table B. And sir. Okay. I'm running a query here. Okay. I'm running a query here. Select star from table. Select star from table A. Where? Okay. Subquery on table B. Subquery on table C. Okay. So now if you run this query, okay, what will be executed first, guys?
Subquery.
Subquery. Okay. So subquery. Query and table B will be executed first. Okay. Then subquery and table C will be executed. Then main query and table A will be executed first. Correct or not? Correct or not, guys? Okay. So normally, okay. So when you have, okay. So, otherwise, okay. If you want to add up one more also. And D. Okay. So first, okay, B, C, then okay, D, then main query and table A will be executed. Correct or not? This is how it will execute. Okay. Now tell me, okay, so normally what I will do, first, okay, this is the step one. Step one. This is step two. Step three. Okay. And step four. Okay. These are the 4 steps it will perform. Okay. Now the question is that, okay, so this is taking 10 minutes. 10 minutes. 10 minutes. 10 minutes. Okay, this is 10 minutes, let's say. Okay, what are the total overall time I am taking? 35 minutes. Okay. But what in case if I enable parallel execution? Okay. Now tell me, sir, okay, is there a dependency on subquery on table B and subquery on table C?
No.
I can run subquery on table B and I can run subquery on table C. I can run subquery on table D parallelly also, right?
Yes.
Huh?
Yes, yes.
In that scenario, when I run all these 3 parallelly, what will happen?
In 10 minutes, all queries will be.
So in 10 minutes, okay, all 3 will be completed in 10 minutes. Okay. So all 3 will be completed in 10 minutes. Because of all 3 are starting parallelly, and this will take as well like 5 minutes. Okay. So overall time will be 15 minutes. Correct or not? Overall time. Okay. So this is what, okay, high VXCC parallel equal to true. Okay. So here by default to execute the stages one at a time. A particular job may consist of some stages that are not dependent on each other and could be executed in parallel, possibly allowing the overall job to complete more quickly. Okay. If you want to enable parallel execution, then okay, you need to enable this one, high VXCC parallel equal to true. Got it? Okay. So by default, this value is not true, it is false. Okay. Then parallel reduced task. What is parallel reduced task? So how many tasks you want to execute? Okay. How many reducer tasks you want to execute? Okay. So you can set a number of reducers like this actually. Set high VXCC reducers max 1000. It means, okay, it can take from 1 to 1000 reducers based on the load. Okay, or you can define, okay, bytes per reducer. You can tell, okay, for every 20 GB data, okay, every 2 GB data, let us take 1 reducer. You can set like that also. Suppose, okay, if mapper output is, okay, 100 GB, okay, then for every 2 GB, it will take, okay, one reducer. You can define on that in that way also. Okay, one is you can give direct number also, you can give, otherwise, okay, you can give bytes per reducer also. Clear? Okay, then use Apache Tej execution engine instead of MapReduce engine. So Apache Tej execution engine is powerful engine. Okay, Apache Tej execution engine is powerful engine, especially for Hive, because, okay, so when it comes to Hive, okay, you will be running small queries only. Okay, so you take, okay, in a day, okay, if 100 people, 100 customers log into internet banking and generate a report, mostly, okay, 100 customers will generate, okay, their account statement only. Account statement is always small. Last 1 month account, okay, account statement, okay, it may give you some 100-200 transactions. Correct. Okay, it's a small data. Okay, they'll not do it. Okay, as a customer, have you ever downloaded, okay, 10 GB data from internet banking as a customer? No, right?
No.
So it means, okay, always, okay, you run small queries on. Okay, so that is the reason, okay, for Hive, better to use Apache Tej execution. And usage of ORC file format that supports compressed storage. Okay, you know, right, what is ORC file format? So usage of ORC file format is always better, okay, for Hive, because, okay, it can compress the data a lot, and, okay, it can save execution time also. Okay, then vectorization. What even a vectorization is? What even a vectorization? Normally, okay, let us take this query, guys. Okay, so we have table A, and I have table B. Okay, inside table A, I have, okay, row 1, okay, row 2, row 3, like this. Okay, 10 rows. So in table B also you have 10 rows. Okay, let's say in table B you have 5 rows. Okay, so now, okay, now I want to run a join command. Okay, so how the join command will work? First, okay, it will take row 1, check with all 5 rows. Row 2, check with all 5 rows. Row 3, check with all 5 rows. Row 4, check it. Row 5, check it here. Row 6, check it here. Like this. Okay, one by one it will go here, one by one. Okay, so that, okay, it will take lot of time to complete. Okay, but if you use vectorization property, okay, vectorized execution enabled equal to true. Okay, if you set these 2 properties, what will happen? Okay, I will not check, okay, one by one. Okay, it will take, okay, it will take 1024 rows at a time. Okay, and compare it here. Got it? So it will take, okay, instead of going by row, it will take, okay, a batch of rows and do the aggregation or scanning or filtering. So that will increase the job performance. Okay, so that is called vectorization. The last one is cost-based optimization. What do you mean of cost-based optimization? Okay, CBO. Okay, if you want to enable CBO, you need to enable these properties actually. Okay, so these are the CBO properties. Okay, you need to enable these properties. Okay, so if you enable these properties, what will happen? Okay, cost-based optimization performs further optimization based on the query cost. Okay, so resulting in potentially different decisions how to order joins, which type of joins to perform first, okay, degree of parallelism and others. Okay, and again, okay, the CBO, cost-based optimization, it is there in most of the databases. It is not only for Hive. Okay, all this vectorization, cost-based optimization. So these are the some of the common features in normal RDBMS also. Got it? So end of the day, how Hive can execute a job, okay, within less time. Okay, so from our side, okay, what we need to do, we need to enable these properties. That's it. Okay, nothing other than that. So it will take care of the rest. Take care rest of the work. Understood? Any questions, guys?
Where are we enabling these things?
Sir, okay, one thing, okay. So just to put all these things. Perfect. So last parameter is not existing, but first four parameters are there. Yes. Okay. Okay. So, sir, okay, when you do these properties here, okay, now I close the session. Okay. If I open the session again, will these properties be there? No, right?
No.
Again, okay, I need to set these properties. Okay. That's the one thing. Okay. But I want to set one property to enable for all people. What to do? So you take this property and go to Hive set exam. So Hive, okay, configuration. So if you put it here, Hive CVO, okay, enable confirmation. Okay, anyway, it is true. Okay, understand? By default, it is enabled. If you enable it here, it will be enabled for all users. Understood? If you make any changes in the Hive configuration, okay, it will be applied for all. And okay, there are some properties which you are using only in your code. Then okay, those properties will work only for your code, not for others' code. Understood? You want some properties to work only in your code, then okay, you put all these things in command line. Then Hive will listen as per you. But okay, you have some properties which needs to be applied for all users. Then okay, you need to put it in the Ambar itself. Got it?
Yes.
Okay. Yeah. These are the performance tuning options that we have in Hive. Okay. Then performance tuning of Hive Server 2. What are the performance tuning of Hive Server 2? Okay, how you can tune performance. For Hive Server 2.
It's availability.
Not high availability, sir. Okay, see, Hive Server 2 is the one, okay, which will be handling multiple requests from multiple customers. Correct?
Yes.
Yes or no? Okay. So Hive Server 2. Now, okay. So Hive Server 2 is a service. Okay. When I say service, okay, it will start in the JVM, right? Yes or no?
Yes. JVM.
Okay. What is the JVM size of this one? Hive Server 2 size. Okay. What is the size of this one? Configuration. Okay. Heap. Just say heap. What is Hive Server 2 heap? 4 GB we have given. Correct or not? 4.5 GB we have given.
Yes.
Okay. 4.8 GB we have given. Okay. Metastore, okay. 1.6 GB we have given. Okay. So what in case, okay, okay, if number of requests are coming and more, okay, those number of requests, okay, until the request is completed, the session information, okay, the query ID, all this information is stored where? Inside Hive Server 2 only, right? Inside Hive Server 2 memory. Okay. So if those server query information, okay, so our number of partitions information, current corrections information is more. Okay, obviously require more and more. Okay, if you have more Hive partitions, table partitions, then you require more memory, Hive Server 2 memory. If you have many concurrent connections, then also you require more memory for Hive Server 2. Okay, when you are executing complex Hive queries, okay, that access significant number of table partitions, then also you need to have more number of, okay, you require more memory set to Hive Server 2. Okay, so any of these conditions exist, Hive can run slowly or possibly crash because the entire Hive Server 2 heap memory is full. Okay, heap memory is full. So if you have too many partitions or okay, many concurrent connections or okay, accessing the more number of table partitions, okay, then Hive Server 2 either run slowly or okay, it may fail also completely. Okay, so how do you identify? Okay, so whether okay, Hive Server 2 is running slow or okay, not running well, okay, not working properly. Okay, how to identify? So HS2 service goes down and new session will fail to start. Okay, it means okay, when you try to submit a query, okay, Hive Server 2 will not accept your query. Okay, new sessions will start to fail means okay, when you try to submit a query, okay, so the new queries cannot be accepted by Hive Server 2. So that is one symptom actually. Okay, then Hive HS2 service seems to be running fine, but client connections are replaced. So if you see Hive Server 2, okay, now if you go to Ambari and if I see Hive Server 2, it will show green only, okay, but no new connections. Okay, it will show the status will be shown as green, but okay, if you submit a query and it will say that okay, query, okay, so unable to submit the query. Okay, it will say okay, so HS2 is busy, is too busy. If you see these messages, okay, then you can say that okay, Hive Server is running out of memory. Okay, query submission fails repeatedly. This is also okay. So opening new session will okay. Opening new sessions means okay. This one okay. If you type Hive here, okay. Now control C. If you type Hive, okay, it will not come. It will stuck there only. Now you can see it is loading, and finally I got the prompt. But okay, in real time, okay, you will see that when you type Hive, it will say loading. You will not see the prompt at all. Got it? Okay, that is one issue. Okay, and queries will fail to submit. Okay? Query submission fails repeatedly. Okay, or okay, performance degrade and displays the following behavior. Okay, if the performance is bad, okay, then query submission delays. Okay, query submission fail is different, delay is different. Query submission fail means okay, if you submit a query, I will not accept the query at all. That is the first thing. The second thing is that okay, query submission is accepting, okay, but it is slowly accepting. If you submit a query, your query is starting after 1 hour. That is also a memory issue. Okay, a long query execution time. Okay, even for small queries also, it is taking for 2 minutes query, it is taking 20 minutes. Okay, so these are all the symptoms of Hive Server 2. When you find these kind of symptoms, just restart the Hive Server 2. That's the only option okay, we have in Hive. Okay, Hive Server 2. Whenever we see an issue, we just restart the Hive Server 2. Apart from that, okay, we don't do anything. Our work is that admin's work is to check okay, whether heap is getting full every time. If heap is getting full, okay, just increase the heap size of Hive Server 2 and start it. Otherwise, okay, if the Hive Server 2 is in a state, just restart it. Nothing apart from this okay, we do. Got the point?
Where can we increase the heap server size? We need to restart the service.
Of course, yes. If you increase the heap, obviously you need to restart the service. Got it?
Yes, sir. Got
it. Where can we see this memory error, sir? Usually
in the job itself, sir. When you submit the job, okay, you will see the job itself.
Oh, okay.
Got it? Okay.
Yes.
So I guess okay, we have only one slide. Okay, we will see this slide and close that today. Okay. So real-time issues from Hive. What are the different real-time issues okay, we can see from Hive? Okay. Hive services are going down with out-of-memory exceptions or any other possible reasons. Okay. Hive services. What are the Hive services here? Okay. Hive services means Hive Metastore service, okay, Hive Server 2 service. So these services are going down continuously. Okay, because of okay out-of-memory exceptions. So if these services are going with out-of-memory exceptions, or these services are entering into hanging mode. Okay, so or they are hung means okay, you need to increase the JVM size or heap memory, and okay, you need to restart service. Second issue is okay, which is very common issues. Hive Server 2 is not responding. So when too many concurrent clients, okay, people are using okay, are running queries on same Hive Server 2. Obviously, Hive Server 2 will not respond. It will go to hung state. Okay. The next one is Hive Metastore service is not respond. Metastore service also same issue. Okay. Even though it is in memory, but still okay, it will have some limitations, right? Okay. So these many connections only it can make. Okay, like that. Okay. So if too many connections are coming on Hive Metastore service also, obviously, okay, it will fail and it will not respond to you. high number of concurrent queries. This is another possible scenario. So if any, okay, let's say, okay, I have another scenario also. Okay, so one recent scenario in development cluster, in production, okay, we have 17 Hive server 2s, but okay, in development cluster we have only 3 Hive server 2s. Okay, but there was some we did some test actually. Okay, performance test. Okay, but again, the performance test, okay, we have given huge number of queries. Okay, automatically what happened? Okay, 2 Hive server 2s were down. Okay, we had only 1 Hive server 2, and all the queries are going to that 1 Hive server 2. So at the end, okay, even okay, that is also okay. That even for that Hive server 2, heap is full, and okay, and it failed. Okay, so this is another issue in real time. Many abandoned Hive sessions. You don't know what is Hive, guys. Okay.
But for memory issues, this developer will get, whoever is querying will get this out of exception or something.
Yes, they will get out of exception, or their queries will not submit at all.
Okay, sir, got it. Yeah.
So then they will reach out to us. Then okay, what we do? We check in the Grafana.
Okay, sir. Yeah, got it.
Okay, Grafana will tell us, right, what is the situation.
Yes.
Okay, so if Grafana heap is full, obviously we will restart the service. Okay.
Is Grafana different for CDP, sir?
CDP is different, right? CDP we have direct chats. Okay. In Hortonworks, okay, we have Grafana.
Okay.
Okay. Then okay, abandoned Hive sessions. Okay, so you don't know what is Hive. Tomorrow I will be covering Hive tomorrow. Okay, I'll explain about that tomorrow. Queries that access large number of table partitions. Okay, so if there is any query, okay, so who is accessing more than 5,000 partitions, then there are high chances that okay, query may fail. But in the later versions of Hive, they increase this limit for more than 5,000. But okay, but this is one of the issue we used to see. Okay, in the older versions of Hive. High query complexity. Okay, so some people will write 2,000, 3,000 lines of query. Okay, so at times, okay, so these 2,000, 3,000 lines of query will access okay, terabytes and petabytes of data. Okay, where resources may not be sufficient to do this one. Okay, so that is also one of the possible real-time issue. Okay, then credentials while connecting from external web applications. Okay, so at times what will happen? This Hive server 2 is enabled with security. Okay, so if you want to submit your query, you need to pass your user ID password at times. Or if it is enabled with Delta authentication, sorry, if it is enabled with Kerberos authentication, you need to pass your PTAP, or you need to pass your Kerberos credentials actually. Okay, so in correct way. Suppose okay, if you don't provide any of these things, obviously your Hive server 2 will not run your queries. Will fail your queries. Okay. Support of correlated queries, subqueries in where class. Okay, so guys, okay, the parallel Hive execution parallel. Okay, this feature is there in the latest versions. The old versions, okay, it was not there. Old versions, okay, it used to run subqueries one after other only. Okay, but okay, these subqueries, okay, if they have some dependency, one subquery is having dependency on another subquery, then okay, if they try to run at a time, okay, then there are chances, okay, of failures. Okay, data type conversion issues and typecasting. Okay, let's say data type conversion means okay, let's say your data type is string, but you are running some time related queries. It may not work. Okay, so we need to look into that. Okay, Hive locking issues. Okay, so Hive locking issues also. Okay, so what is Hive lock issue here? So let's say there is a table. One person is running a query on the table. So let's start from table. Other person is okay, running a query, delete table or drop table. Okay, drop table. Okay, what will happen? One person is reading the data from this table. Other person is running drop table state. Okay, so what will happen now? It's a problem, right? So here only there's the concept of locks actually. Okay, so but now okay, nowadays okay, we don't have this issue because okay, these locks are maintained in common place, which is Zookeeper. Hive also use Zookeeper to maintain the locks. Okay, So if one person is running a select query, other person is running a drop query. So okay, other drop query will understand that it will check in a common place of Zookeeper for any logs. Okay, so if anybody is running a query, they'll have a shared lock or exclusive locks. You know this concept, right? If there is a shared lock or exclusive lock on any table, you can't drop the table. Okay, so now okay, these logging issues are taken care by Zookeeper. Okay, VLAN connectivity, yeah, obviously. So VLAN is a client tool. Okay, so if I want to connect to Hive using VLAN, and if Hive server is not working, you cannot connect to VLAN. This is also one more issue. The next one is SerDes issue. What is the SerDes issue? SerDes means okay, serializer and deserializer. Okay, so let us take this scenario case. Okay, let's say you created a table with comma separated. Okay, comma separated, but you are loading HTML data. Okay, or JSON data. Will it work? You created a table with comma separated values. Okay, but you are loading JSON data. And if you are running a query, okay, select star from table. Will it work?
No.
It will not work. Okay, because okay, see, whatever the table creation format and your data format, okay, both should match. Then only it will work. Otherwise, okay, loading also a problem and retrieving also a problem. Understood? So some people, okay, without having proper knowledge on Hive, what they will do, they will they will create a table with JSON format or okay, CSV format, and okay, they will load the JSON data, and they'll come to us and say, okay, hey, we loaded data, but okay, data is when I try to run select star, when I try to run a query select star from table, it is not working. Why it will work? Because okay, you created a table with a CSV format. Okay, your table properties are telling that okay, CSV comma separated values, but okay, you loaded JSON, it will not work. Okay, Hive core is over H-based tables. Okay, so we don't know what is H-based also as of now. Okay, so we will talk about H-based also in the next class. Okay, then parallel execution of independent stages in execution plan. Okay, so you know at times what will happen. Okay, so if you enable Hive HCC parallel equal to true, parallel execution enable equal to true, and okay, if there are queries started parallelly, and if they don't get enough resources, then they'll wait for 10 minutes and the queries will be killed automatically. Okay, let us try to understand here. Yes. Okay, see, you are running, you enable parallel query execution. Okay, you have only 100 resources. Okay, now there are 5 parallel queries are running. Okay, each query is utilizing 20 resources. Now okay, to complete any query, it requires more resources. Now okay, you ended up in a situation like okay, there are no more resources, but okay, to complete your subquery, you require more resources. So you are in a situation that okay, if some other job release some resources, okay, you will get those releases. But okay, all other jobs also waiting for resources. You are also waiting for resources. So your query will not be successful, and their query also will not be successful. Okay, so enabling parallel execution also not good at times when you have less resources in the cluster. Got it? Okay. So these are the possible real-time issues from Hive-base. So any questions? Any questions?
Sir, of doubt, sir.
Tell me, sir.
The ORC format, the scoop accept changes, sir, files.
No, sir, no. Scoop will not accept.
So the Hive అయితే సపోర్ట్ చేస్తుంది అంటున్నారు సార్.
Hive supports ORC format, yes.
The source database నుంచి ఎలా వస్తుంది సార్ ORC ఫైల్ ఇందులోకి మనకి?
Sir, okay, see, if you want to convert existing data into ORC format, you can use different tools to convert data conversion tools. Got it? Okay. You get the data, convert it to ORC format, then load into Hive.
Okay. The different tool, not for scoop.
Not for scoop.
Okay.
Okay. So basically, if no questions, okay, we'll stop it here. Okay.
Sir, if possible, can you share today's class, sir?
Yes, sir. Definitely. Okay.
Thank you.
Thank you, sir. Thank you, guys.
Thank you, sir.